You can start.
Uh, so today I'm going to tell you about Docker. Docker is a software that allows us to run multiple applications on a single operating system. It achieves this by creating containers on which we can run isolated applications. Docker is actually a platform as a service product that uses OS level virtualization. For example, as evident from this diagram, as can be seen from this diagram, it is kind of like a virtual machine, as you get a full-fledged operating system and you can do almost all of the things that are possible on a virtual machine. But it is very much lightweight, and uh, it does not contain any other applications. Like for example, in a Ubuntu virtual machine, you will have things like Firefox and word processor and all those things. But these things are not required in a container, since container is specifically kind of a bucket that contains only the main softwares, required for running an application. As in a virtual machine, we have in the below most we have the hardware, then we have the hypervisor, and then we have the virtual machines. In these virtual machines, we have all those things. These are kind of operating systems, and everything is there that includes kernels and applications. And on top of that, we install applications. But in Docker, we have on above the OS, we have a Docker engine that contains small containers which are very less in size. So the main advantage of Docker over virtual machine is that it is very lesser in size, and it is very fast and consumes very less resources. That is the main advantage of Docker over virtual machines, and it is used to run applications in containers. Uh, the
But
same
my
thing I
question
have.
is, but you need to configure Docker in a virtual machine, right? First.
Uh, no, that is not required. If I had a base operating system of Linux, we can do it directly. We do not require virtual machine for it.
Okay. Suppose I have a server, okay, on which I need to run some applications. So I can either my apply my configuration of that application, run that application over there,
Uh,
or I can configure Docker and then run the application through Docker on that application. Right.
yes,
On that server, I can run the application through Docker. So
yes.
what will the difference? Because I am adding another application Docker over the server,
Mm-hmm.
right?
Mm-hmm.
So it will consume more resources. So what is why I'm using Docker? Why I'm not directly installing the application on that server then
Uh,
and run it?
ad- ad- Advantages of Docker in this approach include first that the application is isolated. It cannot interact with other applications on the Docker engine if we do not uh, explicitly specify it to. And second thing is that the for example, you have a Linux based operating system and somebody has other Linux based operating system. You would have configured it differently. You have installed different versions of different softwares. One has different versions of different softwares, but these applications can sometimes break and run only on specific versions of operating systems. Docker solve these problems because it is lesser in size. It does not contain the kernel code, uh, only the application specific required to run the software. For example, you have made an application Flask app. It runs on Python 3.6, and uh, we can pack that application into a container, the all the required things, and it will run exactly same on any other machine if we use containers. But if we do not use containers, means it may not run as well, or it may crash. These are the main things that it solves.
Okay.
Uh, and yes, uh, the same way that we install Linux operating systems, the main thing for Docker is the Docker Hub. From that, we can download images and we can make containers based on those images. Which I will show in a few minutes. Uh, we can also use Docker in a virtual machine also, but that is not required. For example, in this example, we can use two virtual machines, and on those virtual machines again we can use Dockers. With Dockers we can create thousands or hundreds of containers with not running all those containers in isolation and not consuming as much resources. Uh, these are the most common Docker commands. Docker run, and this contains the name of the image that we want. For example, Docker run Alpine. This makes a container based on the image named Alpine. We can similarly write Docker on Ubuntu, which makes a container using the image provided by Ubuntu. These its commands are somewhat similar to Linux commands. With Docker PS, it lists all the running containers, and if we provide -a, it lists all the containers whether running or stopped. And if you want to run stop a container, you can use these. And container orchestration is the process of managing those containers. That in Docker, for example, we can create many containers, but we also have to manage them, and we have to manage also how much space we have to give to them. And if, for example, a container crashes, how we distribute its load to other containers. To control those things, we have this is a phenomenon known as container orchestration, and we can use popular softwares like Docker Swarm, Google Kubernetes Engine, and Apache Mesos to achieve it. I have also installed Docker Engine on my system, and now I will show you to run basic commands on it. Uh, the most basic command to run an image is docker run, and the name of the image, which in my case I'm using Ubuntu. If the image is present locally in the system, it will directly create a container of it, and it also exited after containing it, because we did not give any command to do it. Now, if we want to enter the container based on the image, we will write docker run it. This tag is used for making the terminal interactive. And so, uh, meanwhile, I will show you other commands like docker ps. It shows all the containers that are running. And currently, we have only one container running, which has this ID, and this is the name of the image that we use to run this container. And if you want to see stopped containers as well, we can use ps. These are all the previous containers that we have ran. And if we want to, for example, remove a container from it, we can use the docker rm command to remove the container. So let's remove the container with this container ID 5EA1. We do not have to write the full container ID. We can just write the 3 full letters so that that makes it unique from other containers. If we can also write the name of the container for it. And if we run this command, now we will see that the container is removed and the space associated with it is freed. We do not see the container. Earlier it was there. Now it's not. Uh, and if we want to see the images present in right images, it will show all the images that we have on it. And if we want to, for example, delete an image, we can use the command docker rmi and the name of the image. We cannot remove this image because certain containers are based off of it. So we have to remove the container first. And using that, we have only one container, this 5C6. So we'll first remove it. Now it's moved. Now we can remove the image.
I have one
And now,
question that you showcase like how many containers are running currently, right?
hmm,
Mhm. So are they doing anything currently or how it is?
uh, this one container that was running, it was hosting a website on this port. Uh, I,
Okay. So
I
that
will,
means you can able to open that site using
yes, yes,
your local host and that port, right?
yes.
Okay.
I will show it from starting. First, I will stop this container and from starting, I will show RM. First, we will stop the container that was running. It was its container ID is 810. So now the
And now
container,
suddenly you can create another container and on which you can run some other application also, right?
yes, yes. So now we have stopped the container and we will remove it now. And now we have removed the container. Now, if you want to run a website or any application for that matter, we will use the Docker run. Uh, Using the dash p, we will specify how to bind the ports. First, in first, it comes the port of the host, that is our machine which is running it. If we want to, for example, run it on 8008, and then the port of the container, which I know in this case is 5000, then uh, this web app. Since it cannot find this image locally, it will download it from internet and install that container. Now, as we can see, it is running on this 5000 port internally, but to us, we will need to use the port 8008 to access it. We can use it localhost 8008. Oh yeah, it is very a simple website, and we should welcome. And if we run the previous command of this static site, we can also use the dash d flag to detach it. For example, in the previous window, we see that we cannot enter anything, and the terminal is used for showing this. If we use this dash d flag, it will not show that, and it will run the website in the backend. It gives ins the container ID of the website that in which it is created. And if we write the docker ps command, we can see that it is in fact running. And if we want to see the port used by it, we can use the docker port command and use the name suspicious.
But here for running that Docker image, you haven't put any like port ID, port number. So
Yeah,
on which port it will run now?
we have used the dash p flag. It will randomly allocate the port for which
Okay.
in this case it has allocated 32771 on our local machine. And if we go into this port, we will see that this website 32771. So we can see that this is another image, another website.
And if I want to see the logs of the application that is running, then where I have to go?
Some Docker logs, we have for Docker logs command, and then this container ID or the name. Yeah, then we can see the logs of it. And if you
Okay,
want
so
to attach,
okay,
yes,
so but I want to see, like, if I want to copy all the logs in some particular file, then
uh,
see, suppose see, my use case is like, suppose my application is running, okay, from
mm,
last 1 week, and on the third day of the week, I got the report on an issue, so that on the third day I want to check the logs. Like on third day, I want to check the log between 2 p.m. to 3 p.m. Okay,
yes,
then how can I check?
uh, we can use the volume mapping facility. For example, if we know that the logs are going to be created in this file, then we can use this command docker run dash v flag for mapping volumes. This is the address of the host, is my machine. So minus the address.
The thing is, normally when application is running, we have lots of config files of that application, right? It also
Hmm,
have log files, everything. So where
yes.
that files are creating and where have you placed that file? Suppose I have to change the config, then how can I change the config of that application that's running on that container?
Uh, we can enter the terminal for that. I think it
Can you
was the
show me the
command.
terminal of
Is
that application that you're running right now?
yeah. Uh, we have to close this and means we have to close this container and restart it. Then we have to run using this dash it. For example, now I have made a container using Ubuntu image, and now I am inside that Ubuntu container. And if I run all the Linux commands, they will run ls or
Mhm.
ls utr. Similarly, we can you provide this command for that also, and we can see everything, the config files, and edit them using whatever we want. Uh,
Okay.
it works like normal. Linux. Nothing.
Okay. Other thing is, like, suppose I have three applications running on
Hmm,
Docker on each container. Okay, well that means I have three container and on each container one application is running.
hmm.
Okay. Now I have to check the configuration of the second application, not the first, not the third, only the second one. Then how can I go on the black backend or the terminal of that second application?
Uh, Second application, we can use the attach command, I think. First object attach.
Because whenever we have a application running, then most of the time we have to check the configs, its logs, right?
Yes.
So that part is very important. We should know
Mm,
like where we need to go. Suppose I need to restart that application, maybe that application running on Tomcat, then I want to restart the Tomcat. Maybe I have to change the config file of the Tomcat. Maybe I have to change the application code, something.
mm,
So we have to add the, some jars for that application to support a new functionality, maybe.
let me try Box.
Okay, no problem. You can take it up after the KT session. You can show something else that you have prepared for this KT.
Okay. Now next thing, if we want to, as I mentioned about Docker Hub, Docker Hub,
Mhm.
Docker Hub is a platform in which we can access others' images and we can also upload our own images into it. Now I will show you how to upload our own images. Now for that we will use the docker build command. Now as in the present directory, we have if I open it, I have a made application in this directory. Docker curriculum means I will download from net, and from this I will show how to create an image. If we go here, we can see that this Docker file. In this Docker file, we write the requirements used for making the image. If if you open this Docker file, we can see that it is created using the base image of Python, and that this is the working directory. And in this Python, we will see that requirements.txt, the files that are written in requirement.txt will be installed, and the port that the application will expose itself is 5000. I will show you how to make an image using it. First, we'll go cd cd docker.
Sorry.
Now we can use the docker build command. This docker build command uses the instructions given in the Docker file that I just showed you. It will use this command to make an image of it. And we can use the this -t flag to tag the file. And since my username on the net is docker user 40, so I will tag it accordingly. And right, we can add anything after it. For example, let's say 1630. And this will make an image. Oh. So we can see that it is making the image now. And next we can use a docker push command to publish it online. Docker push and then our username, which is docker user 40, and tag means that our username and its tags should match. Then only it will help the docker to find this image.
Okay,
And if we
so
write this command,
my question is like in your Docker image, what all the information it will have?
uh, it will have all the information necessary as we wrote in the docker file. As we
Okay,
wrote in the docker file, this Python, the Python based image it is using, what is its working directory, what ports it is going to expose, and requirements also that is there in other file. This one, this will have all this information, and it is making an image based on its layers. From the bottom layer, we have the more means more general information. As we go up the layers, then from the file will become more and more specific. I mean to say that two or more containers can have same layers. This is another advantage of Docker, as it helps the reduce the space even more. Since we know that it is based on the Python file, so some of its some of its layer is going to be same as the Python file. And now as we have published it online, we can see that here we will be able to find it.
Okay, and the Docker image that you push online, is it visible to you or every person who has an account on Docker Hub?
Uh, I have made it public so everybody who has an account can view it and download it and make images of it. For example, the same way I made the website using the Flask app, anybody
Okay.
can use it. This
Okay,
website.
so one more thing, it won't have any like your computer information, right?
No, it only
Okay,
contains the most necessary information to make this app. That's it. It will use the kernel information from the underlying system that it is
OS.
running. OS. Yeah.
Okay,
Uh, that was it. Thank you.
okay. Let me stop the recording then.